Have you ever gazed up at the night sky and wondered why the moon always shows us the same familiar face? You've probably heard the old tale that it doesn't rotate at all, creating a mysterious, dark side shrouded in eternal shadow. But what if I told you that's not quite true, and that the moon holds secrets far more intriguing than myths? Stick around, because in this video we're diving deep into 10 mind-blowing facts about our closest celestial neighbor that will challenge everything you thought you knew. We'll uncover ancient craters, hidden tunnels, and even plans for a massive telescope on its far side. By the end, you'll see the moon in a whole new light, and you might just question why we're not already living there. Let's jump in. Starting at number 10. What if the moon's hidden side held one of the solar system's oldest and most massive scars, a crater so vast it could rewrite our understanding of planetary origins? Picture this. Deep in the southern reaches of the moon's far side lies the South Pole Aitken Basin, a colossal impact site stretching about 2,500 kilometers across and plunging 8 to 13 kilometers deep. But why is this crater such a big deal? Formed over 4 billion years ago during a chaotic era known as the Late Heavy Bombardment, when asteroids pummeled the inner solar system, this basin isn't just the moon's largest. It's one of the oldest structures we've identified anywhere in space. The sheer force of that ancient collision blasted through the lunar crust, exposing materials from the mantle below. Imagine the energy released, enough to melt rock and fling debris across the surface, creating a window into the moon's fiery past. Now, how do we know all this? Missions like NASA's Lunar Reconnaissance orbiter and China's Chang'e 4 have orbited and landed nearby, gathering data on its unique chemistry. They've detected minerals like olivine, typically buried deep in the mantle, hinting at how rocky worlds like ours formed. Unlike other craters filled with lava over time, this one remains exposed, preserving its raw structure. But here's the hook that might keep you watching. If we could retrieve samples from its depths, who knows what secrets about Earth's own birth we'd unlock? Could it reveal clues to giant impacts that shaped life here? As we explore further, this crater isn't just a relic. It's a key to the cosmos. But wait, there's more to the moon's surface than meets the eye. Moving to number 9. Ever wondered why, despite all our tech, we can't perfectly recreate the moon's dusty surface right here on Earth? It's a puzzle that stumped scientists for decades, and understanding it could be crucial for future space travel. Lunar regolith, that fine, powdery layer blanketing the moon, isn't just dirt. It's a product of billions of years of meteor strikes, solar wind, and cosmic rays, with no air or water to smooth it out. What makes it so unique? Its particles are jagged, charged with static electricity, and vary by region. Some rich in basalt from ancient volcanoes, others in anorthosite from the highlands, even laced with rare helium-3 or metals. Why has replicating it failed every time? Agencies like NASA have tried with simulants like JSC-1, made from crushed Earth volcanoes, but they fall short. These fakes help test rovers and suits, but they can't mimic the real thing's crystal structure, electrostatic cling, or reaction to space radiation. How does this affect us? For building lunar bases, poor simulations mean surprises, like clogged machinery or damaged habitats. Imagine astronauts struggling with dust that sticks everywhere, abrading equipment. But here's the intriguing part. If we crack this code, who could pioneer the first off-world mining ops? As we push toward permanent settlements, this challenge might hold the key to survival. And speaking of building on the moon, at number 8, why does the moon seem frozen in place, always facing us? It's a question that has puzzled stargazers for centuries, and the answer reveals a cosmic dance billions of years in the making. The moon does rotate, completing one spin on its axis in exactly 27.3 days, the same time it takes to orbit Earth. This sync, called tidal locking, means we only see one side, with the far side hidden except for wobbles from libration. But how did this happen? Long ago, the moon spun faster, but Earth's gravity tugged at its bulges, slowing it down over eons through tidal friction, this dissipated energy, locking the pair in a stable embrace. What are the implications? The near and far sides differ wildly. The visible face has more lava-filled plains, while the far side is crater-riddled and thicker crusted. Why? Uneven heating and bombardment shape them differently, We've studied this since the 1959 Lunar 3 probe first imaged the far side. Similar locking happens with Jupiter's moons, helping us model distant worlds. But ponder this. Without this rotation mystery, would we have explored space the same way? It sparks curiosity about what's truly out there. And if you're hooked on far-side secrets, the next fact will blow your mind. Number 7. Imagine landing on a world unseen from Earth, where communication is impossible without clever tricks. Who achieved this feat, and how? On January 3, 2019, China's Chang'e 4 probe touched down in the von Karman crater within the South Pole Aitken Basin, marking the first ever landing on the moon's far side. Why was this so groundbreaking? The far side faces away, blocking direct Earth signals, so China launched the Queqiao relay satellite to the L2 Lagrange point for seamless data flow. What did it discover? The lander and U-22 rover analyzed regolith, measured radiation, and hunted mantle rocks. Surprisingly, a bioexperiment sprouted a cottonseed, the first plant on the moon, though it perished in the cold lunar night. This mission, blending tech and biology, opens doors to sustained exploration. But why does it matter now? It proves we can operate in isolation, paving the way for international bases. As tensions rise in Space Race 2.0, who will follow? This success teases bigger adventures ahead. Number 6. What if we could build homes on the moon using nothing but its own dirt, and robots to do the heavy lifting? This isn't sci-fi. It's the future of space colonization through in situ resource utilization, ISRU. Lunar regolith, abundant everywhere, can be melted with microwaves or lasers to form bricks or layers for habitats. How? Labs have sintered simulants into sturdy blocks, shielding against radiation, meteors, and temperature swings from 173 degrees C to 127 degrees C. Who's leading this? ESA teams with architects like Foster Plus Partners on 3D printed domes. Robots layer regolith over inflatables powered by the sun. NASA and China experiment too, aiming to slash mission costs. No need to haul materials from Earth. Why pursue it? For long-term stays, it's efficient and sustainable. Imagine printing a base kilometer by kilometer. But here's the twist. This tech could terraform Mars next. What challenges remain? Dust toxicity and energy needs, but solving them might unlock human expansion. As we envision lunar villages, the moon's underground might hold even better surprises. Number 5. Hidden beneath the moon's barren crust, could vast tunnels await, perfect natural bunkers for humanity. Lava tubes, formed eons ago when molten rock flowed and hollowed out, might stretch kilometers wide and long. On Earth we see them in volcanic spots like Hawaii, but on the moon no weather erodes them, preserving giants intact for billions of years. How do we detect them? NASA's LRO spotted skylight pits, collapsed roofs revealing dark voids. Gravity maps and radar suggest tubes big enough for cities, shielding from radiation and extremes. Why explore? They could house bases, trap ice for water, and hold geologic treasures. Agencies like ESA and JAXA plan rover descents. But imagine, who might venture in first? These tubes could be our off-world homes. The mystery deepens. Could they rewrite habitability? Stay tuned. The moon's influence on Earth is next. Number 4. Ever considered how the moon quietly safeguards life on our planet? Without it, Earth's tilt, currently 23.5 degrees driving seasons, could wobble wildly from 0 to 85 degrees over millions of years. What would that mean? Chaotic climates, polar summers scorching, equatorial winters freezing, stifling complex life. How does the moon help? Its gravity acts as a stabilizer, damping oscillations via a gyroscopic effect. Simulations confirm, no moon, no stable axis. Why is this vital? It enabled steady conditions for evolution. When searching exoplanets, astronomers now factor in large moons for habitability. But ponder, who first realized this? It's a modern insight from dynamics models. This guardian role makes the moon essential, yet its own enigmas persist. Number 3. Scattered across the moon are bizarre magnetic swirls, bright spiraling patches with strong fields defying a body without a global magnetosphere. Take Reiner Gamma, a vivid whirl on the near side, magnetized without craters or clear causes. Why do they exist? Theories abound. Remnants of an ancient core dynamo, comet impacts depositing iron, or shields against solar wind, keeping areas bright. Probes like Lunar Prospector mapped them, but origins remain elusive. How could we use them? Perhaps for radiation protection in bases. This puzzle teases deeper lunar history. What cataclysms birthed them? As we unravel it, legal questions loom. Number 2. In a universe of possibilities, who owns the moon? Legally, no one, and that's by design. The 1967 Outer Space Treaty, signed by over 110 nations, declares it humanity's common heritage. No sovereignty, no military bases, peaceful use only. But what about resources? You can't claim land, but laws in the US and Luxembourg allow extracting and owning water or helium-3. The 1979 Moon Agreement tried stricter rules but flopped. Why debate now? With mining on the horizon, fair rules prevent conflicts. Symbolic land sales are scams. As space booms, how will we govern? This sets the stage for our top fact. Number 1. What if the moon's far side became home to the solar system's ultimate observatory? A radio telescope dwarfing anything on Earth. NASA's Lunar Crater Radio Telescope, LCRT, envisions a 1-kilometer antenna in a crater, built by robots deploying mesh over natural bowls. Why here? The far side blocks Earth's radio chatter, and no atmosphere lets in low frequencies. It could peer into the universe's dark ages, post-Big Bang, or hunt alien signals. How to build? Climber bots use solar power for autonomous setup. Though conceptual, it promises cosmic breakthroughs. Imagine the discoveries. Who knows what we'd hear? We've seen how Regolith builds homes. Tech advances spacecraft, yet why no lunar bases today? Why the delay in returning? For answers, check our next video. Thanks for watching. Your curiosity fuels the journey. The moon has always fascinated humanity, a silent witness to our past and a gateway to our future. From ancient craters to hidden tunnels and dreams of lunar cities, each discovery brings us closer to calling it home. But with so many mysteries still buried beneath its surface, one question remains. What else is waiting to be found? Could the moon hold secrets that could change our understanding of the universe itself? Let us know your thoughts in the comments. Don't forget to like, share, and subscribe for more cosmic discoveries. Until next time, keep looking up and stay curious.